Okay, ladies and gentlemen, here we go. 2-7 compound inequality. Look at example 1a. The first thing we're going to do is we're going to divide by 2, just like we would in a one-step equation, and then we have the absolute value of x is less than or equal to 3. In the first equation, we are going to have to flip the sign. In the first equation, we're going to leave it the way it is. X is less than or equal to 3. When we solve for the other variable, we have to take the value of the variable, flip the sign, and flip the value because we're working with two values of x, which can be -3 and 3. Now, we are going to do 0, 1, 2, 3, 4, 5. Set up our number line, -1, -2, -3, -4, and then we are going to plot our values of x. So we have that 1 is going to be here and here because it's closed, greater than or equal to. So we have a situation here where x is less than or equal to 3 and x is greater than or equal to -3. So we can write this as an and inequality. So -3, I'm just going to flip this one around. -3 is going to be less than or equal to x, which is going to be less than or equal to 3. So I know that my value will contain all of the values between -3 and 3, in like so. And that's how I would graph that. Of course, you got to make it fit like that. Okay, let's look at our next example. So we have the absolute value of x plus 3. The first thing we're going to do is add 4.5 to each side, just to get the variable, the absolute value equation by itself, like we did in absolute value equations. So now the absolute value of x plus 3 is going to be less than or equal to 12. So our first equation stays the same. X plus 3 is less than or equal to 12. And when we solve for the other one, we go absolute value, the value of x plus 3 is greater than or equal to, flip the sign, and we're going to do -12. So we have -3, -3, x is less than or equal to 9, and over here, -3, -3, x is greater than or equal to -15. So let's look at our number line. I'm going to actually count by 3's here. So -15, -12, -9, -6, -3, 0, 3, 6, 9, 12, 15. So we have whole circles again. So I'm going to put one on -15 because that's what I have down here, over here. And I'm going to put one on 9. So let's think about what I am plotting here. I am plotting that x has to be greater than or equal to -15. And also, I have that x is going to be less than or equal to 9. So again, this is going to be inclusive, and it's going to have all the values of x between -15 and 9. And you would graph like so. Okay, moving on. Let's look at example 2. 2a, I have the absolute value of x plus 10 is greater than or equal to 12. So the absolute value of x, I'm going to subtract 10, is greater than or equal to 2. So again, we are going to set this to two equations. I'm going to have x is greater than or equal to 2, and I'm going to have x is less than or equal to -2. So let's think about what this looks like. In this equation, I'm going to plot these here. So I have 0, 1, 2, 3, 4, and I'm going to have -1, -2, -3, -4. And it's a closed circle, so I'm going to put my dot here and my dot here. Okay, so now I have x is greater than or equal to 2. So that kind of means I'm going in this direction, like that. And I have x is less than or equal to -2. So that kind of means I'm going in that direction. So this one is not inclusive. This one is actually called an OR statement. So The first example, those were called and these are called or. So x can be greater than or equal to 2, or x can be less than or equal to -2. Let's look at the next one. So we're going to solve. The absolute value of x plus 2.5. And then we're going to subtract a half from each side is greater than or equal to 3.5. So we're going to, again, x plus 2.5 is going to be greater than or equal to 3.5. We're going to leave that alone. And then x plus 2.5 is less than or equal to -3.5. So subtract 2.5, subtract 2.5. X is going to be greater than or equal to 1, okay? And then we have -2.5, -2.5, and we have x is going to be less than or equal to -6. So let's plot this. So we have two solid dots. Oh, let's label our graph first. So we have to have a range of 1 to -6. So let's go -8, -7, -6, -5, -4, 3, 2, 1, 0, 1, 2, 3, 4. So closed circles. Let's do a closed circle on -6 and a closed circle. A closed circle on 1. And let's plot our values. So we have x is less than or equal to -6. So this is going in this direction. And this is going in the other direction. X is greater than or equal to 1. So we have another or statement. So x can be less than or equal to -6, and x can be greater than or equal to 1 in order to solve the equation. Okay, let's look at number 3 here. This is a word problem. We love these. A dry chemical fire extinguisher should be pressurized to 125 psi, but it's acceptable for the pressure to differ from this value by at most 75 psi. Write and solve an absolute value inequality to find the range of acceptable pressures. Graph the solution. Okay, so right away we know that we have a couple pieces of key information. The amount we're looking for is 125 psi, but it can differ at most by 75 psi. So really, the value that we're looking for is going to be less than or equal to 75 because that's the maximum amount at which it can differ. So in order to find the range of this value, what you're going to do is you're going to say that you're going to take the absolute value of the pressurized, okay, the pressurized amount minus 125, okay, because that's what it should be pressurized to. So that's how you would write that equation. Now, to solve it, we're just going to go back to our original plan. So we're going to do P minus 125 is going to be less than or equal to 75. Add 125, add 125. So P is less than or equal to 200. Our other equation would be P minus 125 is greater than or equal to -75. Now we're going to add 125, add 125, and P is going to be greater than or equal to 50. Okay? So once you graph this, I'm just going to count by, let's see, I have a range of 250. So I'm going to actually go 0, I'm going to go 25, 50, 75, 100, 125, 150, 175. Sorry, this is tight. 200, 225. That should be good. Now let's check this out. And if we have two closed circles, so we have one at 200, and we have another one at 50, and we're saying that the chemical fire extinguisher should be pressurized to 125. So this actually makes sense and is logical because that 125 is right in the middle. But it can differ 75 psi to the right or more, or to the left. So that means that all values are between 50 and 200. So our answer makes sense, and that's a good way to look at it. Alrighty, let's go on. Here's our next one. We're going to start to do these here. Add 9. Add 9. The absolute value of x is going to be greater than or equal to negative 2. Well, in this case, this is one of those tricky ones, those special cases, because the absolute value of anything is always going to be positive, so it's always going to be greater than negative 2. So this is actually true for any value of x because it's always going to be positive, which is always going to be greater than negative 2. So all real numbers. Let's look at this one. Divide by 4, divide by 4. X is greater than, the absolute value of x minus 3.5 is less than or equal to negative 2. Here we have a negative value of a negative value for the absolute value, and this is going to be true for no numbers, so there's no solution. All right, happy inequalities. The assignment for today is page 145 to 147, questions 20 to 32, every other even, 34 to 52, and 56.